Hello and welcome to this tutorial where today we're going to be focusing specifically on variables. So, a variable is a way for us to abstract away from a specific number or item of data. Okay, so you might remember when you were in math and you learned algebra that you had the ability to look at relationships and you could kind of abstract away a particular value and allocate it to a letter such as A or B or X or Z. It's kind of the same principle here, okay? So we're able to abstract away from a particular number, for example, like 12, and here we're going to allocate it to a variable A. And you know that we are allocating to this variable here because we're actually using an equals, okay? So here we have A equals 12, and that's going to put this particular variable, this value, into our memory. And if I just run this, it prints out 12 to the console as we're basically printing the value of A. So we can allocate multiple values at once to multiple variables. So this is very Pythonic, and that's quite nice. So here we're specifying A, comma B, and then we're going to, on the right-hand side, allocate respectively 67.2 to the B, and then 3.14, so pi, to C. Okay, and when I actually run this, we're going to print B and C, and they've both been allocated, okay. So this is quite nice. You can allocate a single variable a value just one at a time, or you can allocate multiple variables like this, or you can even unpack in Python multiple values into individual variables like this. So you could have A, B, C, D, E, F, and you could unpack values that you have on the right-hand side to those values from a data type, like a data structure that you've imported, for example. So I think we're just emphasizing here that the equals operator is the key thing that you need to look out for in terms of assignment, okay? So we've got lots of examples here, and I'm going to just demonstrate that, that when you actually allocate something to a variable, you can then begin to write over and manipulate those values, okay? So here what we're doing is we're allocating 23 to the variable A. We're then going to allocate A to the variable B, and then when we print A remains as 23, and B has now also assumed that value that we've allocated, so both should be 23. We're now able to write over A, essentially, so A can be equal to 13, as we've got here, but B will independently just remain 23, okay? So hopefully that just provides you with a little bit of an understanding of the flexibility that we have in terms of how we allocate values to particular variables, how we can overwrite particular values, and how different variables are essentially independent of each other at any moment in time, unless otherwise specifically linked. So we could do lots of interesting things. So we could allocate 3 to the letter A, and then we could actually say that we want to add 1 to that letter A variable, which is 3, and we could then reallocate it to that A variable, okay? So then when we do that, we end up with A being 4, okay? Because we basically said we want 3 plus 1 equals to A. We can also do more sophisticated things, like we could allocate values to multiple variables at once on a single one line. So here we have E and F being allocated 5 and 9.8 respectively. We could then specifically just go in and say, well, actually, we'd like to add 2 to E, and then essentially, sorry, let me just run that. And then essentially we could print these out, and when we print these out, we're going to end up with E having become the value 7 because it's 5 plus 2, and then the value F not having changed at all because that's just the 9.8 that we allocated to it earlier. We can also do more sophisticated things, so we could multiply E by 3, so our E value was 7, and 7 multiplied by 3 equals 21, and so on and so forth. You could divide by certain minus numbers, or you could subtract, and these will all provide you with interesting value outputs, okay? I think the key thing is that Python has its own kind of recommended way for you to write code, but also it has a set of specific variable names that you should probably avoid, okay? So I've mentioned before about PEP 8, which I recommend you all go and look at the style guide. If you're writing, beginner to intermediate beginner to intermediate code, you really need to make sure that you kind of pay attention to this, because an expert will be able to look at your code and recognize that maybe you aren't conforming to the style guide that's written. And this really kind of separates out those people who are advanced users from the amateurs. So any sort of job interview that you might want to go to, or any way that you share code with more advanced people, you probably want to put a little bit of time into making sure that you're conforming to the way that we should be writing code. So, variable names, make sure that they start with a letter. I normally wouldn't recommend that you put any numbers in a variable name. Sometimes you have to do that, and that's fine, just don't put the numbers at the beginning. I wouldn't advise that you put any spaces in your variable names. I would recommend that you use underscore characters or hyphens, because spaces obviously can create some sorts of issues at a later stage when you're working with character names and you want to access specific variables. I wouldn't also use cases, okay, so I would make sure that you work entirely in the lowercase, and that's because if you're using camel case, as might be common in other languages like JavaScript, then I would probably suspect that you would make errors at times, you know, when you're working long hours and you look at those variable names, you might not realize that something's a capital, and therefore you might get an error because you haven't correctly referred to the variable name because you haven't got the case correct. So this just helps to minimize particular examples. Okay, helps to minimize potential errors. And we've got some examples here. So we're able to allocate the speed of light. So I believe that this is in meters per second. This is the frequency of GPS, a global position satellite navigation, satellite radio waves, so this is going to be in hertz. And then essentially we have the wavelength here, which is the speed of the light divided by the frequency of the GPS satellite frequency. Essentially then what we end up with is the speed of light, so it's this many meters per second. We have the frequency in hertz, and then we have the wavelength in meters just here, okay? And what we're able to do is we're able to allocate this variable here, the speed of light, allocate the frequency here using this particular allocation. You can see the equal sign, and then get the wavelength by dividing one by the other and allocating it to this variable wavelength. And then all I've done at the bottom is I've just put them into the box, the names, and what this is going to do is it's going to print out those values of these variables to the console. Reserved words, so I did mention that there are a set number of reserved words, so you can't call your list type because type already has a Pythonic meaning, because that's going to be a function which checks whether is going to check the type of an underlying piece of data, okay? So for example, anything that lights up in green, as I've shown here for this simple for loop, is a reserved word. So for, in, range, prints, these are all things that you can't then essentially allocate as a variable name, okay? Great, well that kind of concludes the initial part of this lecture, and you've got the exercise there which you can have a go at. Okay, so thanks for tuning in, and I hope you enjoy working through the material here, and I'll see you in the next session. Thank you, goodbye.